Hello everyone, I am Aditya, fourth year student at IIT Delhi. Imagine a situation where you meet a friend each day and they forget your name every single time. So that's quite annoying, right? So that's how exactly current LLMs agents are. So they are stateless. In this video, we will be discussing about the memory in AI agents. So we'll be deep diving into the memory agents, actually memory in the AI agents. So most LLMs are stateless. So basically they maintain some amount of memory, but as a contextual data. So they maintain past chat history and like context window and tool called results, those things in the as memory. But when they hit a like context limit, all those memories are like lost. So like again, if user asks similar question, then it will not have any memory of previous those things. So that will be quite annoying. So we must have to like add a memory system so that LLM remembers everything we ask or tell them. That's the problem which we will be solving by like developing a memory system for LLM agents. So we will be discussing this architecture in this video. So that's a architecture which I worked upon in my previous internship. Actually, I extended this system design architecture related to like handling many cases like storing documents or and other several things like videos, images as well. But we will be dealing with text only in this video. So we will be taking logs from the front end. So basically when user perform any action, right? Let's say we want a system where we want our system to store like user preferences and user choices. So in this case, let's say you have front end where user like let's say selects a checkpoint maybe, or maybe clicks selects a let's say drop down button. So in this case, we will be like sending those logs or details into the backend for storing into the memory, so that when user asks questions related to those things, we will be feeding those memory into the LLM for generating answers. So in the first step, user will be sending logs. Let's say in this format. Let's say from frontend, user sends logs in this format. Like there will be like user ID, like type. So we will be discussing about type also. There can be type of the memory. Let's say it's a fact, or maybe it can be a fact. It can be a rule. It can be a precedent, or like document, template, argument, notes, tasks, whatever. So this type, memory type actually, timestamp, tags, and actual content, main content which we want to store, and context in which context this memory log was generated, and also metadata, anything extra we want to store in the databases or vector DB. So in the first step, user will be sending those logs from the front end, and for asynchronous processing, we will be storing those logs in the main queue actually. So in case of like burst traffic and making system scalable, we will be using queues for asynchronous processing. So you can like read about asynchronous processing and queues. Like there are several type of queues, and most of them are open source. We can use like Redis as also Redis and RabbitMQ, BullMQ as queues. Yeah, we can also like use Kafka also, as Kafka provides high throughput. So user submitted logs will be sending to the main queue, and we'll be checking type, which we discussed earlier. So based on those types, we will be maintaining like several number of like type specific queues actually. So based on the type, we'll be routing those logs from the main queue to the type specific queues like role queue, fact queue, document queue, maybe image queue also might be there. Then there will be workers which will be working on this type of queues, and taking one log at a time, and maybe they can process 4 log, 5 log at a time parallelly. So usually one picks a log from the queue, and it will be using LLM. It will be like extracting insights actually, like what is the main content of the memory actually, using context, timestamp, user ID, and other metadata. It will be generating a particular text, like let's say we can restrict it to like 2-3 sentences, or whatever you want. And now one problem arrives, that if we keep storing memory, there might be duplicate cases. Let's say in first case, user asks LLM to remember, we have to store data in the DT MMY format, and next time also it asks for the same. So that's case of duplicate memory. So we must ensure that these memories are being duplicated and then stored. So for that purpose, we will be converting those structured text insights into vector DB, so into vector embeddings actually. So there are several vector embeddings model, let's say such as OpenAI, provided by OpenAI, text embedding 3, small and large, and also they are provided by Gemini, and you can use Gemini and OpenAI API for generating embeddings. You can read those docs also here. So after generating vector embeddings from the extracted text, we will be so vector provides a functionality of searching vectors from all of the stored vectors actually. So we will be searching those data in the memory for getting similar type of memories, so that in case of conflict, let's say in one case a user wants to store data in the DD YY format, and in the next time it calls that it wants data to be stored in the let's say YY DD format. So that's a case of conflict, right? Earlier it will be memory will be stored as DD format, but now user wants another format. So for that purpose, we will be searching for similar memories in the vector DB. So that's the architecture here. It will convert data into the vector, and it will search for similar text in the databases and check for conflicts. So there can be several cases of conflict, we want to, there will be there can be several operations we want to perform, we have to merge the previous memory and newer memory, and also maybe we want to discard newer memory, or maybe we want to, if they are previous memory and newer memory are different altogether, then we can also add newer memory. So based on those things, we will be actually adding a memory layer. So in this case, and it will detect conflict. We will be sending top 1 to 3 searched similar memories from the vector DB, and also newer extracted text. And LLM will decide whether it's case of conflict, or it can be stored as it is, or maybe we have to merge previous and newer one. Based on LLM output, we will be performing action adding data, or maybe updating the previous memory, or maybe deleting the previous memory, or merging also. For merging, we can also use LLM. We can actually send previous and newer memory, and LLM will will actually output a merged memory. So yeah, so that's the case. In this way we will be storing databases after like conflict checking and all processing. So that's the whole output. So that's the whole flow, like from input to the main queue, then from main queue to the type specific queue, and then like searching for similar type of memories from the vector DB, and then based on previous memory and new memory, uh, from by comparing using LLM, we'll be performing actions like adding new memory to the vector DB, or maybe deleting memory, or discarding, or merging the memories. uh, so and like for find and yeah so in case of like memory, there can be like let's say we are storing data for 3-4 months, so there will be like lots of memories related to the each user. So we can also add like summarization worker, which we will run like periodically, let's say after 3-4 months, and which will like summarize, let's say here like old memory can bloat the vector DB. There can be, and we need to like summarize all those memories into a single memory item. So like it will fetch all logs per user, and it will summarize and replace with like compact embeddings, so that vector DB will not be bloated, and it will like give proper results. So so this will be the architecture which will be handling like conflicts and also storing memories, new memory. And now we want to use those stored vector DB, those stored memories from the vector DB, so that when user asks questions from LLM agents, it will like gather those memories and will give correct results. So for that purpose, like similarly, user will provide input, right? Let's say user wants to write a legal notice. So we want so the user also want that the date used in the legal notice will be in DD format, as it was stored in the memory. So for that purpose, from the user input, we will be calculating the vector embeddings, and similarly we will be like finding similar memories from the vector DB. Let's say top 10 similar vector memories, and we will be sending those memory logs to the LLM as context. And for that purpose, we will need like proper filtering of the memories. So for that purpose, we will be actually vector. Let's say see how databases are like vectors are stored in the vector DB. So that's a quadrant, that's open source vector DB. There are also like ChromaDB, you can use that, and also like Postgres also provides vector DB, you can use that also. But like quadrant is a like provides managed service, so you can use this only. So it actually stores data in the payload format, the proper text format, and also vectors. So with each vector there is just associated payload. So for that memory thing, we can use like ID, like context, main content, and user ID, L1 tag. So L1 and L2 tag. So these two tags will be used for filtering only. Let's say user wants a legal notice, or maybe legal notice on the theft case maybe. So L1 tag is like less specific. Let's say user want notice, so L1 tag will be notice, L2 tag will be theft notice. So while storing memories, we will be storing those things also. Let's say user provided document and it's a notice document, so L1 tag will be notice, L2 tag will be theft notice if it's related to the theft. So next time when user wants theft memory, like let's say user wants to write a draft using the like draft based on the theft like case. So we want LLM to remember like past memories related to the notice or theft notice. So we'll be using those L1 and L2 tags for filtering. So that's how L1 and L2 will be useful. And yeah, that's all how we will be like using memory, providing memory to the LLM. So it's actually a basic thing. We can extend it to like store many things like document or images, videos, and video transcripts, meeting transcripts. And when user asks a question, we will be feeding those memories by like actually finding similar memories from the vector DB and sending LLM those memories as contexts, so that LLM provides like better results in each case. So this is the basic architecture which we discussed. So and you can also like build your own practice building this thing. Like you can use like quadrant and or chromodb also. Chromodb are basically more simpler one. And you can use like OpenAI key or maybe Gemini API key for generating embeddings. And they're also like if you want to work on a document, so we need to chunk those documents and then like getting text out of it and storing them as memories. It will be like similar one, similar to this current architecture, but yeah, then there's a case of like there might be need of improvement.